So we almost finished with vectors, right? Just unit vector, something called dot product, and to practice, that's it. So unit vectors, what exactly is a unit vector? Well, a unit vector is simply a vector that has a magnitude of 1, and it's represented like this, right? So if I have my column vector, you know the x, well, the number on top represents movement along my x-axis, so the x component. And then the number that's at the bottom represents the movement along the y-axis, so it's my y component. If I wanted to write this in terms of I and j, so I was saying last class that it's actually written as I hat and j hat. That little upside down V on the top is called a hat. So it's really supposed to be I hat, j hat, but when typing, you can't really do that. That's why on the exam papers too, you wouldn't see the hat. You would just see a regular letter I and common letter J. But it's really supposed to have a hat on top, right? You just can't do it when you type it. So this is what you see. This is how you represent a unit vector. So if I tell you if I gave you this vector here, right? This column vector, 3/5 and 4/5. It can be represented as 3/5 I hat plus 4/5 j hat. And like I said, a unit vector is one that has a magnitude of 1. So if this vector that they gave me, this vector, right? If it has a magnitude of 1, that means that it's a unit vector. That's it, right? So just to show you that, I found the magnitude here. So remember to find the magnitude, it's the square root of the x component squared plus the y component squared. So since 3/5 is on top, that's the x component, so that's 3/5 squared plus 4/5 y component, so that's 4/5 squared. You get 9 on 25 plus 16 on 25, which is 25 on 25, and the square root of 1 is 1. So since the magnitude of this vector is 1, it's called a unit vector. Do you understand that?
Yes, miss, I understand.
Okay. And just remember, magnitude is also known as modulus, size, or length, right? Just in case you see those other terms. So there's a formula you use whenever they ask you to find the unit vector, because they will ask you to do that, right? Suppose we are given a vector A, so the name of the vector is A, and you're asked to find the unit vector in the direction of that vector. Then you have to apply this formula. The unit vector is equal to 1 over the modulus or magnitude of the vector. So how would you do that? You would use the formula, the square root of the x component squared plus y component squared. So using the vector that they gave you, you would find the modulus and say 1 over the modulus multiplied by the vector that they gave you. For example, if they ask you to find the unit vector in the direction of vector v, which is equal to 6I hat plus 8j hat, the first thing you want to do, find the magnitude of the vector. So we know that's the square root of the x component squared plus y component squared, x, which would be 6 in this case. So it's 6 squared plus y is 8, so 8 squared. 6 squared is 36, and then 8 squared is 64. 36 plus 64 is 100, and root of 100 is 10. So 10 units, right? That's the magnitude I'm working with. And then the second and final step is to apply the formula. Unit vector is equal to 1 over the magnitude, so the magnitude you just found, multiplied by the vector that they gave you. So we just found out that the magnitude of the vector is 10. So what you do to find the unit vector, you say 1 over 10, which is the magnitude, multiplied by the vector that they gave you, 6I hat plus 8j hat. And simplify. 1/10 by 6I hat would be 6 on 10 I hat. 1/10 by positive 8j hat would be 8 on 10 j hat. But of course, since you can reduce this, you will reduce it. So yeah, you get 3/5 I hat plus 4/5 j hat. And this is the unit vector. Do you understand that?
So basically, what you do is you find the magnitude, and then you plug in the magnitude as the 1 over thing, and then you multiply it by what they give you.
Mm-hmm. And that's how you find the unit vector. That's it.
Oh, that's simple, man.
Yeah, it is.
Miss, could you go
And
back to
just,
the previous slide? Let me just hold a screenshot of that. Okay, thank you, miss.
okay. And just notice that this vector here that I used for this example is the same vector from when I showed you that the magnitude is 1, right? So just a little tip. If you're in your exam and they ask you to find the unit vector, you do all of that and you get a vector, just to make sure that your answer is right, you could quickly, hold on, let me just go back. So let's say you had to do this in the exam and they told you to find the unit vector and you got this to be answer, but you're not sure if it's correct. Check the magnitude. If you check the magnitude of this vector and it's equal to 1, then you know your answer is most likely correct. If it's not 1, then you did something wrong. Check it over, right? That's just a little tip to make sure that your answer is correct.
Understood, miss.
Okay. We move on. Time to practice. Yay. Okay. So the vector A is given by 4i hat minus 7j hat. And they want you to find the unit vector in the direction of A. So all you're doing is do what I just told you, right? Another thing I need to tell you, the unit vector. So say I want to find the unit vector of A, right? Well, of the vector in the direction of A. It would be represented like this, A with a hat on top. But like I said, typing it's kind of difficult because it doesn't have this symbol. But when you're writing, this is how you represent a unit vector, right? So instead of writing out the words unit vector, I could simply put this symbol, the A, which is the vector that they gave me with a little hat on top. And it looks like a upside down V. So the unit vector would be 1 on the modulus of this vector A multiplied by the vector A. So remember the first step you do? Find this. So find the magnitude of the vector that they gave you. Next step, substitute it into this formula to find your unit vector. Can you try that for me, please? And then tell me your answer.
All right, miss, no problem. We'll do.
Thank you. Let me just read the question one more time. The vector A is equal to 4i hat minus 7j hat. So Zafira, since you weren't here when I was talking about this is how you represent a unit vector, right? In terms of I hat. Okay, when I say I hat, I mean this, right? Like it's really supposed to be looking like this. This is called a hat. It's like a upside down V. And it's really supposed to be on top of the I and J, but when typing, I can't really do that. So on your exam papers, you wouldn't see this either. You would just see a common I and common J, because when typing, it's difficult to put the hat symbol, right? But just know that's what they mean. So 4i hat minus 7j hat, that's how you represent vectors, right? Well, that's another way to represent a vector in terms of I and J. When they want you to find the unit vector, you apply this. The unit vector, this is how you represent it, right? Whatever vector they give you with a little hat on top or an upside down V is equal to 1 over the modulus of the vector. So modulus means magnitude, size, length, and remember to find the modulus of a vector or the magnitude of a vector is the square root of x squared plus y squared. So you would do that first to get this value here. And then whatever value you get, it's 1 over that value multiplied by the vector that they gave you. So let me show you what that looks like, right? So just remember, this is the vector, 4i hat minus 7j hat. And we're trying to find the unit vector in that direction. So what exactly do we do? Well, the first step you want to do is to find the magnitude of that vector. So remember, vector A is 4i hat minus 7j hat. And if I want to find the magnitude of this vector, so it's called vector A, right? So I'll say the magnitude of vector A would be equal to the square root of x squared plus y squared. X would be this number, y would be this number. So then what I would write is the square root of 4 squared plus y is minus 7. So just so that I don't mix up the signs, I will put this in brackets, minus 7 squared. And I simplify from here, right? So 4 squared is 16. And then minus 7 squared is 49. 16 plus 49 is root 65. So root 65 units. That's my magnitude, right? That's the magnitude I'm working with. But I don't stop there because that's not what they asked me for. They asked me for the unit vector in the direction of this vector A. So that's just one part of the solution. The other part is to actually find the unit vector using the formula. So can I erase this to continue?
Yes, yes, you can.
Zafira, can I clear this off? Is that so blurry? It is. Okay. So that was the first step, right? Finding the magnitude. The second step is actually substituting it into the formula to get the unit vector. So since this is vector A, I would say the unit vector, remember capital V, give me capital V, upside down V, 1 on the magnitude multiplied by the vector. So to find my unit vector, it would be 1 over the magnitude we just found, which was root 65. And then that is multiplying by the vector that they gave us. And that would be 4i hat minus 7j hat. So let me just put this in brackets, right? When multiplying a scalar value by the vector, I would say 1 over the square root of 65 multiplied by 4i hat. So my answer there, when I say this multiplied by 4i hat, I would get 4 on root 65 I hat. Then I do the same for this one, right? So it's 1 on the square root of 65 multiplied by minus 7j hat, which would give me minus 7 on root 65 j hat. And this right here, that is your unit vector. That's all you have to do to get all the marks. This is the answer. And I was saying before you came in, well, I'm not sure if you came in for that part. If in the exam, like they ask you to find the unit vector, you do all the steps, you get your final answer. If you want to make sure that the answer you got is correct, like the definition of a unit vector is a vector that has a magnitude of 1. So to make sure that your answer is correct, what you can do is find the magnitude of the vector that you got. So since this is supposed to be a unit vector, when you find the magnitude of this vector here, it's supposed to be equal to 1, right? So if you check the magnitude and you realize the answer is not 1, then you did something wrong, you need to check over your working. So let me just show you here. So let's say I was in the exam, I got this answer, but I want to double check my answer. So according to the basic definition of a unit vector, this magnitude is supposed to sum to 1, right? So I would say, if I'm finding the magnitude of this vector, the square root of 4 on root 65 squared plus minus 7 on root 65. That's a 5, right? Squared, not an 8. So simplifying this.
Excuse me, Miss. Miss, what did you put after the 4? Is that an arrow?
This. Wait, where?
1 over the square root of 65 times open bracket 4. What's after the 4?
Oh, 4i hat. That's how you represent it in terms of I and J.
Oh, okay, miss.
Yeah, it's just another way to represent a vector, right?
Excuse me, miss.
Hmm.
Up there on the top right, for the second one, it's like -7 over the square root of, that's not supposed to be 65.
Yeah, it's 65. That's what I was saying. It looks like an 8, but it's actually a 5.
Oh, okay,
Let
miss,
me
my
write it
bad.
again. It's fine. So simplifying this, right? This would give me 16 on 64. I can't be 64 now, 65 plus 49 on 65. 16 on 65 plus 49 on 65 would actually be 65 on 65. 65 on 65 is 1, and the square root of 1 is equal to 1. And therefore, since the magnitude of the vector that I just found is equal to 1, I know that my answer is probably correct, right? Why I say probably? Because I don't know, like, you ever did a math test and your working is wrong, but somehow you end up with the right answer? I mean, it is possible. How? I don't know, some magic went on there. But it is possible. That's what I was saying. Most likely your answer is correct. Because you never know what could happen during that whole thing. But yes, if you get the magnitude to be 1, your answer is most likely correct. Okay? Make sure to double check your work. Okay. So can I clear this now?
Yes, miss.
Zafira, Catania, can I clear it?
Yes, miss.
Zafira. Okay. Pressing on here. Let's continue this practice now. The position, hold on, let me get my little laser pointer. The position vectors of A and B with respect to a fixed origin O are given by OA is equal to -2i hat plus 5j hat, and OB is equal to 3i hat minus 7j hat. Find the unit vector in the direction AB. Okay, one thing I want to point out. In this question, they gave you the vector A and asked you to find the unit vector in the direction of A. That's why we use the vector A, right? Like we found the magnitude of vector A, and then to find the unit vector, we said 1 over the magnitude of vector A multiplied by vector A, right? But notice, in this question, they asked me for the unit vector in the direction of AB, not in the direction of OA, and not in the direction of OB, in the direction of AB. So what does that mean? That means I actually have to find the vector AB and then use that vector to find the magnitude, and then I could find the unit vector by substituting all that into my formula. Do you understand that?
Yes, miss.
Okay. Well, you try now. Let me know when you're done. I'm gonna do it. The position vectors of A and B with respect to a fixed origin O are given by OA is equal to -2i hat plus 5j hat, and OB is equal to 3i hat minus 7j hat. Find the unit vector in the direction AB. And I was telling you, unlike this one, they just gave me one vector, so vector A, and I needed to find the unit vector in the direction of A. So that's why I found the magnitude of the vector A, and then, I did whatever else. For this one though, they asked you for the unit vector in the direction AB. They did not give you AB, but they did give you information so that you can find AB. So that's the first thing you need to do, right? For this question, you need to find AB, and then you'll be able to find the unit vector in the direction of AB. So I'm not gonna have enough time to do that. So let me end and rejoin.